For any three elements, G1, G2, G3, you pick from the group. G1 into, let me say star, G2 star, G3 would be the same as G1 star G2, all star G3. This is called associative law. Okay. So if your group does not satisfy this, it is not a group. Now, but if G satisfies these four axioms, we call them axioms in mathematics, okay? They are like rules to establish a structure. If G satisfies this four axiom, it is called a group. Okay? And normally by notation, we normally write groups using G. Okay? Good. Now, note. There are things we should note. When we say inverse of element, when we say G inverse, when we say G inverse does not necessarily imply 1 over G. Okay? When you write G inverse, you don't necessarily mean 1 over G. Exactly. So when I say G star G inverse, it does not necessarily imply, I mean G n times 1 over G. Okay? Because we are not doing calculations here. Our binary operation can be addition, but star can be equal to plus. Isn't it? In that case, what is G inverse? G inverse will be minus G. Isn't it? So when I write G star G inverse, in that case, I mean G minus G. Exactly. Now this type of groups are called additive groups. Okay. The multiplicative group, of course, for multiplicative group G star G inverse for multiplicative group, if this is multiplication, will imply what? G times 1 over G. Is it clear? This type of group is called what? Multiplicative and so on and so forth. In fact, my binary operation can be symmetric sum, something like this, which is maybe A plus A times B minus A plus B, something like that. Can be anything. So my binary operation depends on the operation I want to implement on my group. Not necessarily plus, not necessarily times. Is it clear? Remark number 2,